Okay, period 4. These are your notes for Tuesday, January 19th. And you should have gotten a guided note page from the substitute teacher. And what I want you to do is take notes on that paper, and I'll tell you when to stop the video and practice problems. Here we go. So here's a problem that is going to involve systems, and we are no longer going to do substitution or graphing. We're going to do something called elimination method, and I think you're going to find that this one's actually pretty easy. The first thing you need to do is you need to make sure that your x terms, your y terms, and your constants are all lined up, which they are. And the goal in elimination is to get one of the variables so that they can cancel out. For example, if you look at negative 4x and positive 4x, if I added those together, that would give you 0, which is what we want to do. So because this one's already set up for elimination, what we're going to do is we're going to take these two equations and we are going to add them together, and I'll show you why we're going to do that. If we add these two equations together, we would get negative 4x plus 4x is 0x, which is what we want to do. We want to eliminate one of the variables. Now, if we add those two terms, we have to add all the other ones. So I'm going to add 3y plus negative 5y, that gives you negative 2y. And if we take negative 3 plus 5, we get 2. Alright, so here's what we have. We have 0x minus 2y equals 2. Well, technically there is no x, so all we have is negative 2y equals 2. Divide both sides by negative 2. And we already know that y is negative 1. So we've already solved for one of the equations. Now, this method is called elimination, but we actually use substitution also, because once we have y equals negative 1, we have to take y equals negative 1 and plug it back into one of the original two equations and solve for x. So if I take y equals negative 1 and I plug it in the top equation, I'm going to do it right over here in the bottom left-hand side. I'm going to have negative 4x plus 3 times negative 1 equals negative 3. So that gives me negative 4x minus 3 equals negative 3. Add 3 to both sides. We get negative 4x equals 0. Divide both sides by negative 4 and we get x is 0. So my answer to this problem is 0, negative 1. Now the one thing you got to make sure of is that you write the answer in the correct form. We want to go x then y. Now of course we always check our systems to make sure that we're right. So if I check this answer and I take 0, negative 1 and I plug it back in to each equation, it should work. So if I go the top equation, negative 4 times 0, that's 0. And if I take plus 3 times negative 1, that's negative 3. Is 0 plus negative 3 equal to negative 3? Yes. So that one checks. If I take it and put it in the bottom equation, 4 times 0 is 0. Minus 5 times negative 1, that's negative 5. So I have 0 minus negative 5. Is that positive 5? Well, yes, so now it checks in both of them, so I know my answer is correct. Alright, we're ready for problem number 2. Now, in elimination, it doesn't always have to be the first variable that cancels out. It could be the second one that cancels out, and we're not always going to add the equations. We either are going to add or subtract. It depends on which operation we use that would eliminate one of the variables. So first of all, if I look at this problem and I ask myself, are the variables and the constants lined up? They are. The a's are in line, the b's are in line, and the constants are in line. If I ask myself, Can I eliminate the a's? Well, if I take 6a plus 2a, that's not going to eliminate. If I take 6a minus 2a, that's not going to eliminate. But if I look at the b's, negative 3b and negative 3b, if I add them, they're not going to eliminate. But if I subtract negative 3b minus negative 3b, that is going to eliminate. That's going to make a 0. So instead of adding these two equations, I'm going to subtract them. So when I subtract these two equations, I get 6a minus 2a is 4a. Negative 3b minus negative 3b. Now remember, that would be add the opposite. So negative 3b plus positive 3b. There's my 0b, which is what I want. And then 27 minus 11 is 16. Okay, so if you get an elimination, if you get to this point and one of your variables is not 0, then you know you've done something wrong. So now I have 4a equals 16. Divide both sides by 4, and I get a is 4. So I'm halfway done, but now I'm going to use substitution and find b. And you can substitute a as 4 back into either one of the original equations. It doesn't actually matter. I'm going to use the top one. So if I take 6 times 4, because I'm going to plug it in for a, minus 3b equals 27. I've got to solve for b. So I have 24 minus 3b equals 27. Subtract 24 from both sides. And we get negative 3b equals 3. Divide both sides by negative 3. And b is negative 1. So my answer, I think, is 4, negative 1. That's really important that you check these because you could make some simple calculation error somewhere. So when I check this, I'm going to take 4, negative 1 and plug it back in the original two equations. Has to work in both. So 6 times 4 is 24. Minus 3 times negative 1 is negative 3. Is 24 minus negative 3, 27. Yep, works in the top equation, but I have to check both. 2 times 4 is 8. And this was a minus when we started the problem. So minus 3 times negative 1 is negative 3. Is 8 minus negative 3, 11? Yes. So I know my answer works, so my final answer is 4, negative 1. Okay, here's problem number 3. 2x minus 32 equals y, and negative 60 plus y equals negative 2x. Well, first of all, this one is not set up for elimination at all because my x's and my y's and my constant are not lined up whatsoever. Now, if I really was given the opportunity to use whatever 3 methods I want, whether I use graphing, substitution, or elimination, this problem is actually set up for substitution because y equals 2x minus 32. But we're doing elimination today, so we have to figure out what are we going to do so that we can do this problem with elimination. So the first thing I'm going to do is I'm going to get all my x's and y's on the left side and my constants on the right so that I can line up my problem. So 2x minus 32 equals y. If I move the y to the left and the negative 32 to the right, that's going to become 2x minus y equals 32. Now, if you're not sure how I got that, I subtracted y from both sides and I added 32 to both sides. That way my x's and my y's were on one side and my constants on the other. Now the second equation, if I move around everything, that's going to turn into 2x plus y equals 60. And again, the way I did that was I added 2x to both sides and I added 60 to both sides. That way, everything's lined up. All right, so now, if I look at this equation now, or the system now, 2x minus y equals 32 and 2x plus y equals 60, I can add the two equations and get rid of a variable, or I can subtract the two equations and get rid of a variable. So if I subtracted 2x minus 2x, that would eliminate a variable. If I added the two equations, negative y plus y is going to equal 0. It's up to you which way you go. You're still going to get the same answer regardless. Me, I like to do addition because of the fact that when you do subtraction, you got to be very careful with all your signs. So I'm going to add these two equations. And you get 2x plus 2x is 4x. If I take negative y plus y, that gives me 0. So right here, my y's are gone. I don't even have to write them. I've been writing them, but you don't have to. And then I get 32 plus 60 is 92. So my y's are gone. I'm going to divide both sides by 4. And I get x is equal to 23. So x is 23. Now, of course, I have to find y. And I'm going to plug x back into one of the original two equations to solve for y. So I'm going to use the top one. And if I take 2 times 23 minus 32 is y. This gives me 46 minus 32 equals y. So y is supposedly 14. So my answer is 2314. But of course we're going to check it because we want to make sure that it's right. Again, there's no reason not to check it because you know that you can get these all right if you just check them every time. So if I go back to the top and I take 2, and you always use the original equations. 2 times 23 is 46 minus 32. Is that y? Y is 14. And yes, it is, so we know that one checks. Alright, if I take the answer and I plug it in the original bottom equation, that would be negative 60 plus 14. Does that equal negative 2 times 23? Well, negative 40 plus 14 is negative 46, and negative 2 times negative 20 times 23 is negative 46. So I know my answer checks out. So I know I am correct on my final answer. Okay? Problem number 4. Okay, problem number 4. Alright, this problem, first of all, it is not set up for elimination, and there's some work we need to do, first of all, just to get the problem ready. 3x minus 5y equals 11. There's nothing I can do to that. That one's fine. On the bottom one, I'm going to do the distributive property, and I get 5x plus 5y equals 5. So the first thing I had to do was I had to get the two equations ready. Alright, now that I have the two equations, 3x minus 5y equals 11 and 5x plus 5y equals 5, I'm going to ask myself, can I add or subtract them and eliminate the variable? If I take negative 5y plus 5y, that would eliminate. So I know I'm going to add these two equations. So I'm going to add them together. And we get 8x, negative 5y plus 5y is gone. We don't need to write it. 11 plus 5 is 16. Divide both sides by 8. And x is 2. Okay, now I need to find y. Now, just a precaution, you always want to take and substitute the variable back into one of the original two equations, not the ones you changed, because if you made a mistake when you changed them, you're going to get a wrong answer. Alright, so I'm going to take the top equation, and I have 3 times 2 minus 5y equals 11. We get 6 minus 5y equals 11. Subtract 6 from both sides, and we get negative 5y equals 5. Divide both sides by negative 5, and we get y is equal to negative 1. So my answer is 2, negative 1. And again, we're going to go back and check it just to make sure that it is 2, negative 1. So if I go back to the original equations, 2 times 3 is 6, minus 5 times negative 1 is negative 5. Is 6 minus negative 5 11? Yes. On the bottom, we have 5 times 2 plus negative 1. Is that negative 5? Well, this is 5 times 2 plus negative 1 is 1. 5 times 1 is 5, or whoops, it was supposed to equal positive 5, sorry. 5 times 1 is 5, and it checks out. And so my final answer is 2, negative 1. Okay, I'm going to have you try this example by yourself on your note page, and then when you're ready, come back to the video and I'll go over it just to make sure you have the correct answer. Alright, so the first thing you had to do was ask yourself, should you add or subtract these two equations? Because they're already lined up, the x's, y's, and constants are in the correct order. This is one of those problems where you could have added them or subtracted them and been able to use elimination. So I'm going to do it one way. You may have done it the other way, and that's okay. So let's see what happens. I'm going to actually subtract these two. There's no easier way. You can add or subtract, doesn't matter. I'm going to subtract them. The only thing you need to make sure that you're always careful of if you subtract is you have to remember that you have to watch your signs real carefully. So if I take 2x minus 2x, that's gone, which is what we want. If I take negative y minus positive y, that gives me negative 2y. 32 minus 60 is negative 28. Divide both sides by negative 2, and I got y is 14. Alright, now I need to solve for x. If I take it and y equals 14 and plug it in the top equation, I have 2x, and I have minus 14 equals 32. So that gives me 2x equals 46 when I add 14 to both sides. Divide both sides by 2, and x is 23. So regardless of which way you did it, you should have gotten that x is 23 and y is 14. Now really quickly, let's check it. 2 times 23 is 46. Minus 14, is that 32? Yes. If I take 2 times 23, that's 46. Plus 14, is that 60? Yes, so I know my answer is correct. Okay, here's another one. I want you to try it by yourself and then come back and watch me go over it. So pause the video right now and work this one out. Alright, this problem was not set up for any kind of elimination yet. So the first thing we got to do is we got to reorganize the problem. I'm going to take that top equation, and when I rearrange everything, I get x plus y equals 8. And the way I got that was I added y to both sides, and I added 8 to both sides. Okay, so I rearranged it. The bottom equation, it's already in the correct order. I just need to turn around the front. So I get 2x minus y equals 6. All right, now we're ready for elimination. All right, this one you have to add the 2 because we are going to eliminate the y. So if I add everything, x plus 2x is 3x. Y plus negative y is 0. That's gone. 8 plus 6 is 14. So when I divide both sides by 3, x is 14 thirds. Okay, I need to find y, so I'm going to put this in the top equation. And I get 14 thirds minus 8 equals negative y. So this is 14 thirds minus 24 thirds equals negative y. That gives me negative 10 thirds equals negative y. Divide both sides by negative 1, so y is 10 thirds. So right now it looks like my answer is 14 thirds, 10 thirds. Okay, and again, especially since I have fractions, I want to make sure I check this one. So if I take the top equation and I have 14 thirds minus 8, does that equal negative 10 thirds? This is 14 thirds minus 24 thirds. 14 minus 24 is negative 10 thirds. So I know my answer checks in the top one. In the bottom one, I have negative 10 thirds plus 2 times 14 thirds, that's 28 thirds. Does that equal 6? Well, negative 10 plus 28 is 18 over 3, and 18 over 3 is 6. So it does check, even though it was kind of an ugly answer. So my answer is 14 thirds, 10 thirds. Okay, hopefully that's plenty of examples on elimination, but I will tell you that in your book, we are in section 6.3 right now. And if you look at pages 348 to 350, there are also more examples worked out in case you feel like you need to see even more examples. But what you're going to do now for homework, and it's due tomorrow, is you're going to do page 352, and you are going to do problems 8 through 18 evens. Make sure you solve them and check them. I would also like you to try number 19 and 20, and I will fair warn you that those two have word problems in them, but the first thing you're going to do is translate them both into two equations and then solve them. And then I also want you to do problem 24 and 26. Okay, so hopefully these notes have helped, and you need to have this assignment done by tomorrow, and I will see you tomorrow. Have a good day.